Welcome, everyone. Thanks for joining us here today. My name is Chris Thomas. I'm a regional sales SE for NozomiNetworks. And what we're going to do today is a deep dive into some of our products. Should be a fairly quick agenda. This is what we're going to cover today. I'm going to do an overview of the Nozomi solution, why you need it, where it fits. Talk a little bit about the basic architecture, which I've got a little graphic here. And then we'll get into some of the details around what our solution does and why it's important. So rather than bore you with these slides, I'm going to flip over. I'm going to kill that right now. And I'm going to flip over to my browser and actually show you active stuff. I had brought a little device here that is running my software. Our software can be done on-premise, in the cloud, etc. Unfortunately, it's not working. I'm not getting a network connectivity as I expected. So I'm going to pivot a little bit, and I'm going to talk about and demonstrate another aspect of our product, which is our software as a service, or SaaS product that we have up in the cloud. So first of all, let me tell you a little bit about Nozomi, what we do, and why it's important. So Nozomi is at its base, is an intrusion detection system, threat detection, asset visibility, and vulnerability assessment solution for operational technology, or OT networks. Does everybody know what OT means in this room? All familiar with that? Excellent. So unlike IT networks, where you can, do penetration testing and scan ports and everything to determine where your vulnerabilities are, in the OT world, in operational technology, industrial control systems, that kind of scanning, that kind of active spray and pray penetration testing and solutions of that nature are verboten. We don't do that. Reason being, in the OT world, a lot of these controllers, PLCs, these are very prescriptive devices. They are purpose-built to do one thing and one thing only. If you try to do a port scan on some of these things, they will fall over. In the ICS and industrial control system world, where when these things fall over, that can have real impacts in the world. That can crash systems, that can harm individuals and safety systems, etc. So at Nozomi, we developed a solution to give you that industrial, or sort of give you that IDS solution, but in a very passive manner. So what we do is we've created a software system that can live on purpose-built hardware, or virtual machines, or even containers that can live inside of your industrial control system network. And rather than, like I say, scan out and actively try to figure out what's out on your network, we primarily operate in a passive mode. So we will take a copy of the traffic that you see in these industrial control system networks, ingest it into our solution, analyze and parse different protocols, etc., and figure out what's happening in your network, rather than doing it actively. Does that make sense?
Can we ask questions now? Or
I encourage you to ask questions as you go, absolutely.
Okay, practically, I need to have a span port for a tap in each critical point for that to. Do you recommend anything? Are you providing, I don't know, at least recommendation for span port?
Absolutely, yes. Half of my job is, when I come in and position this solution with customers, is to do an architecture diagram like this and to figure out exactly that. How do we get the traffic out of your control network
sure that you are
into the tool? And you're right, network span is a very popular option.
But expensive.
Where you can't do span, if you have some of these line switches down here, some of these industrial switches, they're not built like a comprehensive IT switch with a lot of different supporting options, like remote span or any of those. So a lot of these times we'll come in here and that'll just be a dumb switch, very little management configuration capabilities. So what we'd have to do there is we'd look at deploying like a network tap, like a Gigamon, or there's other more cost-effective and more industrial-focused solutions like a Garland, for instance, would be a good solution there. But the idea is just to get a copy of the traffic into our sensor. The sensor in this case is called a Guardian. So you can see here we've got Guardian sensors deployed. In this particular example, I've got 3 of them here. So the Guardian is where all the heavy lift is done. It's where all the protocol parsing is done, the deep packet inspection, and we build what we call a virtual image of your operational technology, your OT, your SCADA network. We build it inside the Guardian, and then we watch for anomalies, etc. Okay. Now I was going to show you that interface. Sure.
What's the difference between remote collector and Guardian?
Great question. So in our portfolio, you can see here, I've really got 4 pieces that make up the solution. The Guardian is kind of the brains. That's the non-optional one that you can deploy it, hardware, software, virtual, etc. The remote collector is another option, hardware or virtual option, that acts as a remote Guardian interface. So in this case here, I've got a switch, I've got a span, I'm sending data directly into this Guardian, no problem. But let's say over here, let's say this is in a bunker somewhere, this is I can't go and deploy a full Guardian there, but I have network connectivity, I can deploy a very small remote collector that effectively acts like a remote interface on this guy. So the remote collector would come and connect to the Guardian and feed this data directly into one of the sensors. So it's kind of like think of it as like a mini Guardian. But what it does is it sends it to an actual sensor, an actual Guardian.
Specific questions. I
Sure.
have 56 substations. I will put the remote collectors in each substation and a big Guardian somewhere.
Smaller Guardians across.
Smaller Guardian.
Yeah, depending on it, again, there's no one size fits all with this solution. I will say we customize the deployment every time we talk to a customer. No two OT networks are the same, in my experience. Everyone does things a little differently. And for example, in this diagram, you can see each of these line switches are isolated. They're not connected to each other. They're not connected to the core. They are in complete isolation. In this case, you have to deploy a Guardian in each specific location, and then we'd have to figure out a way to get traffic from those up to a central management console. So a couple of other components in this solution. If you have multiple sensors, our recommendation is to roll them up into a central console for management. In this case, we have an on-premise solution called the CMC. It's optional here. That can roll up multiple sensors, and from that console, you can see each of the sensors, you can focus in on each one, etc. I also had a demo with the CMC ready to go, but unfortunately, I'm having a bit of network connectivity issues on my laptop. So what I'm going to show you today is the 4th and final piece of this solution, which is called Vantage. You see that up at the top. Nozomi was the first, and we are the primary provider in this space that provides software as a service options for OT. A lot of customers say to me, I don't want to send my OT data out to the cloud. Question?
Just a question to the gentleman here that will follow up. So, and you mentioned substations. You have a number of substations. In today's world, there's substations that have access like dark fiber and things like that, but there's still a lot of them out there. Same thing with oil and gas that have radio-based communications to a lot of these sites. What's the traffic requirement coming out of, say, a Guardian? Like, do I need to kind of rebuild the whole network to be able to support? Because right now, a lot of these spots have enough for me to support minor commands to a PLC or an RTU in the field.
Right, exactly. We run into this all the time. It's a great question. Again, that gets into more deeper architecture kind of questions, and I can certainly, if we want to take that offline, we can do that. But what I will say is that we have solutions to that. For example, if I were to put a simple Guardian here, the bulk of the traffic would remain local. The only thing that would be sent up would be metadata. So 10% or less of the actual generated traffic. If I was going to span this traffic from here up to a central Guardian, then I'm duplicating my the entire network traffic in that. For sites with radio links, we generally don't do that. It depends on how much bandwidth and how much availability, how much headroom you have in those networks. But those are the kind of things that we will, in a pre-sales role, we will come and help you architect that if you choose a solution. We also have full professional services that can do a deep design of your deployment in this case. Okay. So this is going to be a deep dive. I was going to show you a demonstration of the Guardian and the CMC, but technology being what it is, I'm having a little trouble getting my little Intel NUC connected in properly. So what I'm going to do instead, I'm going to kind of pivot, and I'm going to show you this piece up here called Vantage. Now, Vantage is a full SaaS solution. This is the Vantage demo environment that I have here. The the way the system works is it breaks. Did I kick something? Oh, there we go. We're back. Wonderful. So the way that this system works is, again, to recap, the sensors generate, they collect data, they generate, we lost it again.
Because most presenters are not so outgoing, you know.
Oh, so am I flapping my arms too much? Is that what's going on?
Oh, wait, I'm just using those cables.
Okay, I'll stay on this side of it then.
Another connectivity problem. This happens all the time.
Okay. Come on back. Love live demos. They are the best. There we go. Okay. I'm going to stay as far away from this as possible. Exactly. I should have brought a laser pointer. Okay, so to recap, the Guardians do the heavy lift. They do all the processing. We send metadata from the Guardians up to management. What I'm going to show you now is management in the cloud versus management on-prem. Okay. Now, a lot of my customers in specific OT environments say, "My OT data in the cloud? Are you crazy?" We tackle that problem in a couple of different ways, which I will show you. Some of my customers are perfectly happy taking metadata and putting it up, encrypted up into the cloud. Depends on the customer, depends on the environment, etc. So our cloud solution is called Vantage. This is the window here. I've just logged in. It's welcoming me back. And what I'm going to do is use Vantage as sort of the central point to show you the data and show you some of the solutions that we can bring to bear down closer to your process network. I was going to show you the Guardian, but having a little difficulty, we'll go with what we got. So in the Nozomi solution, the first step is to identify what you have. You guys you've all been in security. You know that you can't secure what you can't see. Very common theme there. So the first thing we do on these networks is we search out and find out what assets we have. Now, the nice thing about industrial protocols is when a programmable logic controller or PLC sends data to an HMI, or it's a human machine interface where your operators will work, a lot of these protocols embed information about the asset directly in the stream. So like a Rockwell PLC talking Ethernet IP, a lot of that, there's certain register values that will send direct information about what that Rockwell PLC is, what firmware version it has, etc. So we can grab all that information as we see it pass over the wire and start to build out a list of assets that we see in the environment. So rather than just show you a list of assets, which is boring, I'm going to show you the way we, oh, there we go. It's logging me out. Give me one sec. Logging back in. There. I'm going to show you our funky graph. So this graph is built on the fly with real-time data of what the sensors see as far as who's communicating to whom, on what protocols, and detailed information on the device. So I'm going to zoom in a little bit because that's a bit of an eye chart. So you can see it's learning that information as we go. It's gleaning this from this. In this case, Vantage is actually gleaning this from the sensors on site. And so now I have individual devices, assets out here in blue. The blue ones are considered producers, so they're generating data, and they're sending it to a red device, which is a consumer. So this would be like an HMI. So I can show you some of the detailed data that we can get. So I just clicked on one randomly here. This one is an AC800M controller from vendor ABB. And if I want to go and check details, I can see a lot more detailed information about this device. This was all collected completely passively. At no point did we pull this device or query this device or send any active traffic into this OT network. This was all just gleaned passively. There's a couple of other components in our solution that are optional that you can leverage to get this type of detailed data. One of them is an asset intelligence feed. So we have partnerships with all the major vendors, Rockwell, Siemens, Honeywell, all these big OT vendors. And we work with them, so they send us detailed feed information about their products. So that we can then say, well, that's what it looks like. Here's a picture provided from the vendor. Here's all the detail around it. And In some cases, we can even get detailed information around end of life, end of sale. So if you're out there, if anyone attended Vivek's talk earlier this morning, he was talking about the life cycle in some of these OT networks. Unlike a typical IT network, it is not a 3 or 5 year life cycle of these products. Some of these can be out there for 10, 20 years, right? A lot of this is legacy out there. So getting end of life and end of sale information from the vendors is critical in some of these cases. So we can glean all of that using a combination of the passive ingestion that we talk about, plus this asset intelligence feed that we get from the vendors. We merge it all together, and we provide you with detailed information about your asset. Unlike a static asset solution, like, you know, recording all this stuff on a spreadsheet, if something changes in the environment, we detect it, we reflect it in the tool. Okay, so that's asset visibility. Just want to do a time check. Okay, good. When we collect this information from an OT network, once we have asset information around product, firmware, etc., we can then determine where we're vulnerable. When we have all that information, we then can translate that into vulnerabilities. So here we are. This particular asset shows these level of vulnerabilities and the CVEs that are associated to them. This brings me to the second feed, optional feed that we can bring into our box, which is our threat intelligence feed. So once we, if you enable that through a license on the Nozomi system, we curate at Nozomi. We have a Nozomi Labs based in Switzerland that actively looks for OT-specific threats in the wild, curates specific CVEs from different vendors, and brings them all together into the box. So when we know the firmware and the type of device we have, we correlate all that with the vulnerabilities that we know about and package that all here for you to view quite simply. Now, patching. Vivek talked about patching in his talk earlier this morning. Unlike the IT world, OT, we tend not to patch these boxes very frequently. Sometimes some of these boxes run proprietary software. Some of the HMIs are running Windows, but they might be versions that we have long forgotten about. Like, I still see Windows XP out in the wild all the time, right? Because that's how the vendor built their system. And if you try to upgrade that to Windows 10, first of all, the hardware probably wouldn't support it. And second of all, it would probably break all the software that they built 20 years ago for these systems. So we look at these vulnerabilities for some of these older systems and say, yeah, we understand that Windows XP has 1,500 known vulnerabilities, and we present that to our customers, but we don't expect to say, well, just upgrade that to the latest Windows 11, off you go, right? We try to look at other mitigating circumstances and come up with other compensating controls, like segmentation. So one of the things we can do out of this graph that I was showing you earlier is show how that segmentation is possible. So I'm going to come back to this funky graph. This graph is showing me, again, it's not a physical representation of the network. It's showing me who's speaking to who and what protocols. But the way it's color-coded can be changed. So I can do things like, I can filter out this by specific things and focus in on specific things in my environment. So let's just say I wanted to see a specific vendor. Let's just see my Rockwell PLCs. There we go. Don't have many in this particular environment, but there's one. Again, it's drawing its map live as it sees this traffic. So I can focus in on things like that, specific vendors. I can also focus in on specific zones. So we have, if you remember, if anyone saw Vivek's presentation, or if you remember this diagram, we have a concept in OT that's commonly referred to as the Purdue model. It's also known as IEC 6443. We allocate assets and devices into specific levels for to identify what they are functionally and how we secure them. So in a Purdue model like this, what we generally say is no level. We should have compensating controls in here to ensure that no device on any level can talk outside of its level beyond 1. So something at level 1 can talk to devices at level 0, and they can talk to devices at level 2 with compensating controls to make sure that something at level 1 should never talk to level 3, etc. Something at level 2 should never talk to level 0. So we do these kind of things. Now that is the Purdue model. In our tool, we can further granular around grouping devices together. Not only in Purdue model, we can also do what we call a zone. So a zone can be something that you can define. And in my case here, I'm going to search by zone, and I've created a few zones that I've called production networks or ProdNet. So I'm going to say, show me my ProdNet 02 network. So now it's going to just fold in on those devices that I have allocated to be in this particular zone. So I have the ability to understand where I'm segmented, how my zones are created, who's talking to who, and most importantly, I can look and see if my segmentation has been deployed properly as a compensating control. Do I have any devices talking between zones? I likely will, but I want to be very prescriptive around it. Do I have any devices that are talking between Purdue model levels? In this tool, I can go and see, do I have any devices at level 1 that are talking to level 3? And the tool will proactively show me that very, very easily, and then I can go and take steps to mitigate that type of misconfiguration, right? Any questions on this so far? Wonderful. I love being clear. Okay. Let's talk about threat detection. So we talked about asset visibility. We've got that down. With asset visibility comes vulnerability assessment. We understand where we're vulnerable. But now what we want this thing to do is actively monitor for threats. Now in the OT world, it's not just your typical malware that we want to look for. And we certainly have that. As an example, I will show you. I'm going to flip over here and show you some alerts. So we do watch for things like malware. Here's an example of an alert generated in this network when I ran through some traffic that was infected with WannaCry. So we have two devices speaking. One of them transferred the file via SSD, and that file was clearly infected. So what we do in this tool with these alerts is we bring all of this together. We can, of course, take these alerts and we can send them out to other systems like SIMs or other tools. But we can also give you a great deal of information directly in this tool. So if you wanted to send this data to your SOC or give your SOC access into this tool, they can see these alerts in real time as they're coming up. And then we can even do things from an incident response perspective by defining playbooks to say, when you see this kind of alert, here's what you do. Here's your playbook. And this is completely editable, as you can see. I can click here and change this. So these are completely definable. For your organization, if you have a malware file in your OT network and you have a specific set of actions that you want to take, that can be easily put into a playbook. We also map all of this down at a great deal of detail, even down to the point where we automatically map it into your MITRE ATT&CK framework. So in this case, malware in the MITRE ATT&CK framework for ICS is mapped to the loss of productivity and revenue. So again, this can help you in your incident response. And yeah, we have a great, we show a great timeline of these alerts, etc. Yes, questions?
So I have all these vulnerabilities, what do I do now?
Well, that's the thing I was talking about before. Vulnerabilities in an OT network, it's important to understand where you're vulnerable, but it's not as simple as just patching the system to remove that vulnerability. We will recommend that sometimes in the case of, if it's a Windows XP box, we will say, here's some patches that you can implement to mitigate that, but you can't always do that. So our system never mandates a fix, right? Because this is an intrusion detection system. We generally don't do anything automated to resolve these issues. That can cause more harm than good in an OT environment, to be honest, but we will certainly make recommendations. So there's no direct fix. The question then becomes, you see these issues, you see these vulnerabilities, and we work together to determine what your best course of action is. Usually segmentation is your best course of action in that case. Where was I going to go here? I was going to show you. I lost my train of thought for a moment. Oh, yeah. Sometimes I'd say this is mainly a passive solution, as I mentioned. Sometimes that's not enough. Sometimes you're going to have devices that don't tell you everything you want to know on the wire. Windows is a good example, right? If I have a Windows XP box up there, it does not tell me what version it is. I can glean that information from some of the traffic that I've picked out. But like as far as what Windows patches that device has, I can't tell that over the wire. I can't sniff a packet and pull out patch levels from a Windows device. It won't tell me that. So we have an option in the Guardian sensor that's called a smart poll. We have the ability to use smart polling as an option to do very targeted, protocol-specific polling of a device. So I told you earlier, we don't do that because, like we do on the IT side, because that can actually bring a box down. But what we do is something like that, but very targeted. So for instance, if I have a Rockwell PLC that speaks Ethernet IP, that is an industrial protocol. If I were to just port scan that guy, I could bring him down. But if I targeted a Ethernet IP query to that box, he would expect that. That would be something that he could then respond to without causing any issue, without creating any risk in the environment. So we have something we call smart polling. I can't show you in this system because we don't smart poll from the cloud, we smart poll from the sensor, which is unfortunately not working for me. But what I can show you is some of the results of that. So I've got a Windows box in my environment previously, and I've given it a name called Windrunner. If anybody's a science fiction fan, you might know what that means. I've got this computer. This is a virtual machine running in my environment, and I have used my sensor on my Guardian to do a smart poll using WinRM for this particular box. So I've gone in and asked it a bunch of questions about itself. What it can tell me here, again, just like every other thing, I can see vulnerabilities, etc., but it also can tell me patches and software that I have running on this box. So that is a way we can get around some of the limitations